let's look at simultaneous equations where one or both might not be linear, right? We just earlier in the class, we talked about simultaneous equations where both were linear. And I did mention that, well, sometimes one might not be linear or the other one might not be, or both might not be linear, right? And now that we have done quadratics, we can now tackle situations where you have a pair of simultaneous equations and, well, one or more of the equations might not be linear, right? And that's what we have here. So let's look at a few examples. So here you have a pair of simultaneous equations, x squared plus y squared equal 10 and 2x plus y equal 1. And the method that will be useful here is the method of substitution, right? Notice how substitution is used to solve this pair of simultaneous equations. So we took the linear one, and that might be the one that is better to use in most cases. So you have from equation 2 or the second equation, you can make y the subject. You see that y is equals to 1 minus 2x. And now you take that 1 minus 2x, right? So you take this one, you make y the subject, so you get y equal to 1 minus 2x. You take that 1 minus 2x now and you put it in the place of y there. And this is what you get. This x squared comes back here. Y squared, remember y is 1 minus 2x now. So you're putting 1 minus 2x in the place of y and square it, equal to 10. Now what you have here now is a quadratic. It's not, what should I say? Solution ready, meaning it's ready to be solved immediately. You have to do some work to simplify it, right? So you do some work, simplify it, simplify that, notice. You expand out the bracket and so 1 minus 2x squared gives you all of this here, right? What's happening here? You expand out 1 minus 2x squared, you get this. Simplify further, you get that. Factorize, you get that. And then you solve, right? And you get two values for x. But you're not done yet. Remember, you had two simultaneous equations that had y inside, right? So you now have to find the corresponding y values for each of these x's that you have here. So you do that. When x is minus 1, you substitute in this equation here, and you will get a corresponding y value. When x is 9 over 5, you substitute in this again, and you get y equal 13 over 5, right? So your solutions are x equal minus 1, y equal 3, or x equal 9 over 5, y equal 13 over 5, right? So those are your solutions. Another example. So you have two here, and in this case, both of these equations are nonlinear, right? Both of them are nonlinear. So in this case, I want to think, I don't know, they use, you can use substitution. You can use elimination very easily here too. Let's see what they did. Oh, they use elimination. You add the two equations and the y squared, the minus y squared gone, and you're left with 3x squared equal 12. And you solve, right? You solve. That shouldn't be hard to solve. So you get x equal positive 2, x equal negative 2. You substitute that in any one of the equations to get the corresponding y values. And you get, okay, you get positive and negative 4. You get positive and negative 4. So what's going on here? It's good to get a diagram to see what's going on, right? Because you have now 4 solutions, right? So let's see what's going on. I think there's a graph to show you what's going on, right? Let's see. I think one is, yeah. one of these equations later on. The maths people tell you one is a hyperbola, I think, and one is a what is that? A circle or an ellipse? Yeah, let's see. Oh my. Oh. I think the all right. During the next class, remind me to show you what the graphs look like. Let me do that. Let me just show you. Let me just show you these two graphs. Let me write it down. 2x squared plus y squared equal 24. I just want to show you why we got 4 solutions, right? 4 pairs of solutions here, right? What should I say? Yes, 4 sets of coordinates. Let me go to the Desmos and let me just show you. So I have 2x squared plus y squared equal 24. Okay, that's an ellipse, yeah. And the next one is x squared minus y squared equal negative 12. Okay, good, yeah. So if I'm gonna make it a little smaller, yeah. Oh my, it's too small. So yeah, what you're seeing here is that the reason why you had 4 solutions is because the 2 graphs, right? 2x squared plus y squared equal 24 is this green ellipse here.
Sorry,
And x squared minus y squared equal minus 12 is what we call somebody say something again just now?
Sir, I don't know if it changed the screen yet. It's still showing the working for the 2 functions.
Oh my, all right. Yeah. So those are the 2 graphs, right? The green is the ellipse, 2x squared plus y squared equal 24. And the purple, x squared minus y squared equal minus 12 is what we call a hyperbola, right? It's what we call a hyperbola. Yeah, that's what it looks like, right? Good. So you notice that they intersect 4 different places. Watch, they intersect here. That was one of the solutions. They intersect there. I think there's an error here. Yeah, that's it. Yeah. They intersected minus there. Yeah, they intersect here and they intersect there, right? You see the 4 intersections?
Yes, sir.
Yes, sir.
Yeah. So that's a graphical approach to getting all the points of intersection, right? So notice one of the pairs of equations that we solved use substitution, the other one use elimination, right? So you can expect those kinds of things, right? So I think now we're ready to close off. So